Okay, today's lesson maybe will bring together the co-function ideas, sine, cosecant, tangent, cotangent, cosine, secant, maybe why they're named the way they are, and how the S goes with the C and the C goes with the S. Before we get started, let's do some warm-ups. For the provided triangle, we need the requested information. So they are looking for the sine ratio for R. Right away, I'm going to put the 10, the hypotenuse in the denominator, and then I go get the side opposite. And then it says, okay, I'll find angle P, reference angle P, and write the cosine. Well, again, I put 10 in the denominator and get the side adjacent. And probably I could reduce that to 4/5. It didn't ask me to simplify, but it's a good practice. Okay, go to the next box. They want the sine of P. Again, I put the hypotenuse in the denominator and I go opposite reference angle P. They want the cosine of R. Again, the 10 goes in the denominator because it is so ka toa. So we've got the hypotenuse always in the denominator of sine and cosine. And then because this is the cosine, I find the reference angle and the side adjacent. Ooh, and this is 3/5. And what do I notice about the ratios in each box? The ratios are the same. So the sine of R is the same as the cosine of P. Those two complementary angles. And the sine of P is the same as the cosine of R, which is kind of a good fact to know. If I have to be finding the sine ratios of any triangle, I could just find the sine and cosine of one angle and then flip them for the other. This is because a very special relationship exists between the complementary functions, which are called cofunctions, sine and cosine, of right triangles, and their complementary angles. The co prefix in the word cofunction stands for complementary. So if we consider the triangle ABC with right angle C, angles A and B are complementary angles because the sum of their measures equals 90. The trigonometric ratios also have complementary relationships. So let's just prove out 90 minus x plus x does equal 90. So what we need to do is use this triangle above here to go ahead and write the various cofunctions. So these two are cofunctions because they're partners in crime, an S and a C. These are cofunctions, a T and a COT, a COS. And then we have secant and cosecant. That's CO again for cofunction. So if I go to my triangle, I find the reference angle X, and I need the sine of angle X. Well, first thing I'm going to do for all of these ratios here is they're all in the same triangle, and C is in the hypotenuse of each of these. And I know I have so, ka, the hypotenuse goes in the denominator. So I don't even have to really think about that. Now I have to sort of concentrate and find my reference angle and get the side opposite. Find my reference angle, get the side adjacent. Find my reference angle, get the side opposite. Find my reference angle, get the side adjacent. Tangent is TOA. So I'm going to find my reference angle, opposite over adjacent, reference angle, opposite over adjacent. Now cotangent is going to be the reciprocal of tangent. So this is going to be A over B, and this will be B over A. And the secant as you recall, is 1 over the cosine. So I just need to take the reciprocal of these. So instead of A over C, it's C over A. Instead of B over C, it's C over B. Likewise, the cosecant is the inverse or reciprocal of the sine. So instead of B over C, I put C over B. And instead of A over C, I put C over A. And then I want to take a minute to analyze this chart because I'm going to have to do some filling in the blanks. And what I'm noticing is I'm going to circle the things that are the same, the ratios. So those two match. And these two match. A little flower there. And look here. These two match. Identical. And these two are identical. So there. These two are identical. And also these two are identical. C over A and C over A. So using the chart here, we're going to complete the given statements. The sine and the cosine, it's got the co in there, are co-functions. The sine ratio of an angle is equal to the cosine ratio of its complement. Therefore, the sine of an angle is equivalent, or you could write equal, to the cosine of its complement. So if we just write this down using numbers, the sine of 30 is equal to the cosine of 90 minus 30. Here. Or we could rewrite that as the cosine of 60. Okay, the blank and the cotangent. So the tangent and the cotangent are co-functions. The tangent ratio of an angle, so we'll call x, is equal to the cotangent ratio of its complement, 90 minus its value. Therefore, the tangent of an angle is equal to the cotangent of its complement. So if we wrote that with numbers, we could write the tangent of 60 is equal to the cotangent of 90 minus 60. The secant and cosecant are co-functions. The secant ratio of an angle is equal to the cosecant ratio of its complement. Therefore, the secant of an angle is equal to the cosecant of its complement. All right, for each right triangle, name the given ratio in two different ways using co-functions. An example is provided. So they give us the ratio of M and R. Okay, M is on the hypotenuse, so I'm thinking it's going to be one of those ratios with the hypotenuse, so either so or ka, right? Now I have to see m over r. Well, it's going to be the reciprocal of these because the hypotenuse is in the numerator, so I'm thinking this is going to be cosecant and secant. And then here's our reference angle. We've got the secant of n, hypotenuse over adjacent, is equal to the cosecant of r, the opposite over, or excuse me, the hypotenuse over the opposite. Kind of, if you get one of them, the secant or the cosecant, you find the correct reference angle and then you use the other acute angle or the other ratio. All right, so we have ratio BA. So that's hypotenuse over some sort of side. So I'm thinking this should probably be secant, cosecant, or could be sine OB over A. So that's got to be, yeah, secant or cosecant because I have the hypotenuse in the numerator. So the ratio B over A would be the secant ratio, so that's going to be the adjacent over the hypotenuse for reference angle N. Ooh, forgot my L there. And the cosecant ratio hypotenuse over opposite for the reference angle A. Got this one down here. We've got F and C. Or I'm sorry, F and E. Okay, again, excuse me, we have the hypotenuse, so I'm thinking this is going to be cosine or sine. Here I've got not the hypotenuse in the numerator, but the side in the numerator, so it's one of these two. So let's pick the cosine ratio. For which angle? Well, that would be angle E, right? The side adjacent over the hypotenuse. And then it's going to be the sine ratio for the other angle for reference angle F. See, both of these things change when we're talking about cofunctions. I'll be talking about cosine and sine, an angle, and then its complement, or one of the acute angles and the other acute angle. Right, and then in this triangle here, we have E over F, ain't no hypotenuse at all. So I know I'm talking about TOA, so I'm talking about tangent and its cofunction cotangent. So I'll start with E over F, that's opposite over adjacent, for angle E. So this is the tangent ratio for the reference angle E. And then I know the other angle is going to have to be F, and it's going to have to be cotangent, and I'll check it. The cotangent of F, we would have our adjacent over our opposite, which would be the cotangent. All right, now we're kind of going back to just a word problem, and it's fairly involved because there's lots of triangles within triangles. So what we need to do is read through the problem and then just take it a step at a time. So this is very much scaffolded here. Diane is training for a charity bicycle marathon. She leaves her house at noon and heads due west. She is pedaling this direction. And she averages 4 miles per hour. At 3 o'clock, which they were nice enough to do distance is rate times time, so that would be 3 hours. times 4 miles per hour to get to 12 miles. She changes course to go north and also west. So she's going this direction here. And she does that for 2 hours because this is now 5 p.m. And again, they did 2 hours at an average of 4 miles per hour, which would be 8 miles. All right. And we need to figure out where she is located in reference to her house. Not how many miles she's biked, because we've got that. 12 and 8 would be 16. But relative to if she was to turn around right now and bike back home directly, not the same route, how far away would she be? I think we have to kind of do this in steps. And they were nice enough to kind of put the details of the information and provide the drawing for us. And what we really want to find is what z equals. Now, if we had the y and this length, we have a right triangle there, we could use Pythagorean theorem, but we're missing 2 key pieces. I think I still want to go for Pythagorean theorem, but we need some work to get x and y. All right, for this we need to find the angle measure here, because that's the angle that's in this right triangle, and I could use sine or cosine or tangent or something. So to do this, we use the fact that this angle is complementary to the one we want to find, because if this is 90, then that has to be 90. So we take 90 minus 65 to get 25. All right, so that's a start there. So now I can build, I put that in there, and I can build some ratios. I have a hypotenuse, and I have the side opposite, so I would write the sine of 25 as the side opposite over the hypotenuse, and then I also need x, so now I'm going to use the cosine of 25 is the side adjacent over the hypotenuse, and then we would solve for y and x. Now we do not want to round at this time. We want to use the exact value for both of these. We want to wait until the end to round. If we put an approximation here and an approximation here, and then we approximate again for our answer, we're going to have an answer that's significantly different than what we should actually have, because we have rounding error built into our answers. And maybe back in the day when we had to do this by hand without fancy calculators, this is the way we have to do it. But we can put this all in our calculator at once. We want the square root, and then in parentheses are y squared, 8 sine 25 squared, plus, all in parentheses are x squared, 8 cosine 25, plus 12, because we need this whole length for the Pythagorean theorem. And then we hit enter, and we get that z is 19 point, and now we round to put our miles in. And then something for you to think about, would there be another way to solve for z? Because we have all kinds of right triangles, I think there's other methods to perhaps find this segment and find this segment, add them together, use some other tricks. So kind of think about alternative methods that you could use to solve for z.